In today's note, we're going to be solving problems involving linear systems. So this is going to be incorporating what we've done in the last two notes, where we've solved by either substitution or elimination. But now we're going to be looking at it in more application terms. So a couple steps that we want to go through when we're going through these problems is the first thing we want to do is, because we're dealing with word problems, we want to determine what our variables, x and y, what they're going to represent. Number two, we want to come up with two equations to represent the scenario. So in any given scenario, there should be two kind of equations that we can come up with. Helpful hint, one is going to be really easy and the other one is going to be a little bit more complicated. But as long as we kind of recognize what we're looking at, then it should be helpful. And thirdly, we're going to solve the linear system by either substitution or elimination. So when we're dealing with these problems, there's no particular method that you have to use. You can use either substitution or elimination. If there is one you'd rather use or you're more comfortable with, you can use that. However, there are some better options depending on what the equations tend to be. And the last thing we want to do is write a therefore statement, because we are dealing with word problems. So we should have a concluding statement or a therefore statement. So in example 1, Mr. Lou's cat has 8 mice and balls to play with. So 8 total of the mice and balls. For his birthday, he wants to double the number of balls he has. If he does, he will have a total of 11 mice and balls. How many mice does Mr. Lou's cat have now, and how many balls? So what we're going to do is actually go through and come up with two equations and figure out what our variables are going to be. But let's at least go through and reread the question, highlight anything that's important. So the first important thing is that he has 8 mice and balls to play with. So that means in total he has 8 toys, and they're comprised of mice and balls. For his birthday, he wants to double the number of balls that he has. And if he does that, he will have a total of 11 toys to play with. And then what the question is looking for, I'm doing a different color. We want to know how many mice does he have now and how many balls. So we need to have our two variables, so x and y. We need to let them represent two things. The easiest thing to do is to let them represent what we are trying to find. And what we are trying to find here is we are trying to find, first, the number of mice, and secondly, the number of balls. So that's step 1. So let me rearrange this. So these are what we are trying to find. So those are usually what your variables are going to be, the two things that you're looking for, or the two things that the question is asking. So number 2, we need to come up with two equations. So the first equation is very straightforward, and that comes from the first part of the actual question. I'm going to highlight that in a different color. I'm going to highlight that in a blue. So the first equation, we'll call it equation 1, is that Mr. Lou's cat has 8 mice and balls to play with. So that means in total, if you take the number of mice, add the number of balls, he will have a total of 8. The second part, or the second equation, comes from the second part of the question. So for his birthday, he wants to double the number of balls he has. So if y is the number of balls he currently has, if we double that, it's 2 times y. The number of mice stays the same, plus x will equal a total of 11 toys in total. So those are my two equations. Now, These are my two equations, so now what I'm going to do is solve by either substitution or elimination. Now, neither equation is actually set up where it's isolated for one variable, so that would make having to solve by substitution have an additional step. So I'm going to solve by elimination. So what I am going to do, I'm going to take my two equations, I'm going to place them on top of each other. X plus y equals 8. And then I'm going to rearrange the second one slightly. X plus 2y equals 11. So I'm just going to put them into order. So it's still equation 1, still equation 2. Now looking at these two equations are very ideal for solving by elimination, because if I look at the x values, and I'll highlight them, say in a pink, if I look at these two values here, the number in front of them is the same. It's both 1. So that means that I can either add or subtract these two equations to easily get rid of these. And because the signs are the same, I am going to subtract these two equations. So x minus x is 0. Y minus 2y is negative 1y. 8 minus 11, equal sign is still in the spot. 8 minus 11 is negative 3. So I've solved by elimination, or that's what I'm doing. So I'm solving by elimination. I subtracted my two equations. I got rid of the x's. I'm left with negative 1y equals negative 3. Now I need to solve for y. So I'm going to divide by negative 1, divide the other side by negative 1. One side cancels out. And I'm left with y equals 3. So I'm still trying to solve my point, find my point of intersection. I've solved for my y value. Now I need to solve for my x value. So I need to plug y into an equation. And again, it doesn't matter what equation we use, similar to the last couple notes we've done. It doesn't matter which equation we substituted in for. I'm going to use equation 1 because it's the easiest, right? It's the most simple, and you could probably do it right off the top of your head. So x plus y equals 8. I know my y value is 3, so x plus 3 equals 8. And right from here, a one-step equation, you could probably solve this on your own in your head. But I'm going to go through and solve it. So if I want to get rid of the plus 3, I have to minus 3 from both sides to keep it balanced. And I'm left with x equals 5. So that means x equals 5. So if these were just two equations of lines, I could say that the point of intersection is 5, 3. However, I'm going to use a therefore statement because these two variables don't just represent a point. They represent actually the number of mice and the number of balls. So that means, therefore, his cat has 5 mice, because remember x represents mice, and 3 balls, because 3 represents the number, or y represents the number of balls. So that is our therefore statement, which summarizes what we found. We're going to look at another example. We're going to go through and read the question, and then we'll go back and highlight any important information. So for the ice hockey teams, Mr. Lou is buying hockey socks for all of the players. The medium-sized socks cost $15 per pair, and the large-sized socks cost $18 per pair. Mr. Lou orders a total of 80 socks. He spends $1,365. How many large pairs did he buy? How many medium pairs? So we're going to go back through and highlight any important information. So some key information. So he's buying socks for the ice hockey teams. that's not really important. What is important though is the cost. Medium-sized socks are $15 a pair. Large sizes are $18 a pair. He orders a total of 80 socks, and he spends $1,365. And then finally, we're looking for how many large pairs did he buy and how many medium pairs. Actually, we'll use just a different highlighted color. So we need to represent or let our variables represent two different things. Again, looking back at this, what are we trying to find, right? That's what we looked at last time. What are we trying to find? So this is what we need to use to help figure out what our variables are. What are we trying to find? In this case, what we're trying to find is the number of medium pairs. So let X represent the number of medium socks, and let Y represent the number of large socks. So now we need to come up with two equations. And what that's going to do, or what we're going to need to do with this, is look at two different things. There's two different aspects to this. The easy one, again, is just going to be equation 1, X plus Y equals X plus Y equals 80, because the number of medium socks plus the number of large socks is going to equal 80 socks in total. For the second equation, rather than dealing with the actual numbers, we're dealing with the cost. So for the medium socks, it was $15 per medium sock, and then plus $18 per large sock, and in total you spend $1,365. So that's my second equation. So looking at this now, there's two ways that I can do this. One, I can solve by elimination, right, if I wanted to, or I could solve by substitution. Either way, in this case, there's going to be a little bit of work, because if we look at the numbers in front of each letter, they're not the same. So that means I would have to take one equation and multiply it, and none of the equations are isolated already for a variable. But however, since we solved the last one by elimination, just to get another example of substitution, I'm going to solve this one by substitution. So I'm going to solve by substitution. Let's just take this and move it over. So if I solve by substitution, I need to take one equation and isolate it for a variable. So I'm going to do that with equation 1 because it's very easy to do that. So if I have X plus Y equals 80, and what I want to do here in my goal is isolate a variable. So get a letter by itself. Again, it doesn't matter what letter we choose. And in this case, it's not going to matter either way. So let's isolate for X. So if I want to get X by itself, I have to minus Y. So 80 minus Y. One side will cancel out. So I have X equals 80 minus Y. So I've isolated one equation. Now what I need to do is take this equation and sub it into another one. So I need to sub into the other equation. So I'm going to take this equation, sub it into the other one. So that means it's going to be 15. I'll write it out. So 15x plus 18y equals 1365. Instead of x, I can replace x with 80 minus y. Everything else stays the same. And similar to when we solve by substitution, we have to take this 1 and multiply it, or this 15 and multiply it to everything in the bracket. So that means 80 times 15. So we get 1200 minus 15y plus 18y equals 1365. I can combine these y's together. So I get 1200 plus 3y equals 1365. And now I need to solve for my variable. So if I want to get the y by itself, I need to get rid of this plus 1200 by subtracting 1200. Do it from the other side. One side cancels out, and you're left with 3y equals 165. And if we take, to solve y, we divide by 3, divide by 3. One side cancels out. We're left with y equals 55. So we know our y value is 55. So again, the last step once we find one of them is to go back up on here, sub y into an equation. So if I'm going to sub y into an equation, I'm going to use the easiest one. I'm going to use x plus y equals 80. X plus y I know is 55 equals 80. If I want to get x by itself or solve for x, I need to minus 55 from the other side, and I get x equals 25, which is my final answer. So again, because this was technically solving a linear system, if I wanted to, I found the point of intersection, which was 25, 55. But in reality, because we're actually dealing with a scenario, therefore he bought 25 medium socks and 55 large socks. So again, the hardest part about this would be coming up with the equations and then figuring out which method to use, elimination or substitution. However, the actual type of method doesn't really matter. Either way, you would still get the same answers. So the biggest goal here is just coming up with the equations, and then you can use whichever method you're comfortable with.